Hey everyone, welcome to the third episode of Heistmeisters C#. We are going to continue right from where we stopped on the last video. And in this video, we are going to do three things. The first one, we are going to map on the input mapping our keys for movement for the character. We are going to start to instantiate the scene for the player from the template character scene. And we are going to start moving our character only up and down at first, okay? It's going to be a lot for a beginner series, but just follow along and it won't be a problem. With that being said, step number one, you need to come over project settings. Yours is probably going to open on general, just go to input map. And you can see over here that I've already created mine. Move up, move down, move left, and move right. You could ask me like, well, Gustav, why make that when we have already UI left, UI right, UI up? Well, it's because UI left, UI right, UI up, etc. They are made for the UI. And I mean, you could use them for that. You could add more keys for that, but always try to be simple, alright? Simple is better than complex every time. So don't try to mix it up because otherwise later you might make yourself confused, okay? With that being said, to create a new key, let's just delete the move right so you can see it, the process. It's very simple. Just type how you want to name it over here, move underscore right. Click on add, click on this add icon over here, key. You could add joy button, joy axis, but that's something for later. Just press the key over here. Click on OK, and that's it. You have assigned a key for this input mapping, okay? So step number two, well, before step number two, save your project. Step number two, go to scene, new inherited scene. It's going to ask you, well, from which scene do you want to inherit? It's already open over here, the template character. It's the one I want. So I just click on open. It will start a new scene that at first is a clone from the template. Yeah, that's nice. That's what we want. But then we're going to change the name for player over here. The sprite for this sprite over here on PNG, Hitman 1 over here. Nice. We're going to save it in the same folder for characters. Nice. And over here, we're going to unattach this script and create a new one with this template over here. And we're going to call it player. Okay, create it. Well, over here on the code, we have to pay attention to some things. The first one is that at first, this script is inheriting from kinematic body 2D. What does inheritance mean? Well, to put it simply, it's just that this class over here, although it only has like 13 lines, it actually has all the properties and methods from kinematic body 2D. But we don't want that. We want this class to inherit from template character. So all we need to do is delete it and type template character. Okay, why do we want that? Because first of all, template character already inherits from kinematic body 2D. So player, in a way, already inherits from kinematic body 2D as well. And we want to have those variables over here, speed, max speed, and friction. At first, they were private. But since we are going to now be using them in our children, I've changed them to protected, which means that I can access them in classes that inherit from them, but not in classes that have nothing to do with that, okay? With that being said, let's just script a simple movement over here. If you want to learn a better way to move, although a bit more complex, I'll put a video on the card over here so you can see it. It's an intermediate C# series. Otherwise, just follow along. We're going to create a private variable. Remember, we're going to create everything private at first, except the methods from Godot, that they must be public. We're going to create everything private at first and change it later if we need so, like we did with those variables over here. We have changed them protected, and we might change them to public later if we need so, okay? Private vector2 motion equals to new vector2 like that. What does that mean? Well, on vector2 is just a simple, well, it's already written over here, two-element structure that can be used to represent positions into this space or any pair or any other pair of numeric values. It's just like a vector in math or physics, with an x-axis for the horizontal movement and a y-axis for the vertical movement. Nice. We won't be needing the ready method, so we are going to delete it, okay? And the process method over here, we're going to change it to physics process. Why are we going to do that? Well, I'll explain that in a bit. Just follow along for now. First thing we're going to do is update movement. It's a method we're going to create right now over here. Private, because we don't want anyone beyond this class to access it. Void, because it won't be returning anything. Update movement. Receives nothing. And what does it do? We'll do that later. And then after updating movement, we're going to move and slide with motion. Well, and that's where we're going to explain why we're using physics process. If you read the description from OpenSlide, you can see over here that this method should be used in physics process, as it uses physics steps delta value automatically in calculations, otherwise the simulation will run at an incorrect speed. So that's very simple. We mostly have two methods in Godot for dealing with something we want to do at every frame: process methods and physics process. But when we are going to do movements, and that's the case over here, that relate to physics, like move and slide, that's a very common method in Godot, we just need to use physics process. That's very simple, no need to complicate it, okay? With that being said, inside update movement, we're going to type the following: if input is action pressed, move up, the same move up that we created earlier, else if input is action pressed, move down, we're going to do something else, else we're going to do something else. And what is that we want to do? Well, we want the motion variable that we created earlier only on the y-axis to be subtracted by speed. Whose speed? Speed is the same speed over here. You can see that if we change our inheritance, like to kinematic body to t, suddenly the code can't understand whose speed, because I mean, whose speed? Kinematic body 2D doesn't have any speed inside it. So we just change it back to template character. Nice. And this notation over here is the same as doing motion.y minus speed. But since that makes you type something twice, it's simpler to simply do that over here. The same thing for movement now, except in the opposite direction. And you might ask me right now, well, why are we subtracting the speed when we are moving up and adding it when we are moving down? That makes no sense. Kinda. In game engines like Godot, it's usual to have the y-axis inverted. What I mean by that is that when you go down on the screen, the value for the y is actually going up. So that's why we're subtracting for moving up and adding for moving down, okay? However, if we're not doing any of those two, we're just going to change the y-axis to 0. Well, to 0. Oh my god. Well, let's see what does that do in our game. Back here in Godot, we're going to save our project, drag our character over here, otherwise the camera would crop it in half and it would be hard to see since we're going only to move up and down. And instead of clicking play, which would make Godot ask us, well, which one's the scene that wants to be played every time, etc., etc. We're just going to play this scene over here, okay? You can either press this button or type F6. Wait for that to build, and over here, if we press S, the character will go down, W it will go up, and if we stop pressing anything, it will stop right away. Why does that happen? Because, as you have seen in the code, when we are not pressing either W or S, the y-axis goes to 0 instantly. So that's why the character stops instantly. That's going to be it for this video. I know it's been quite a lot for a beginner series, but don't worry, because in the next one, we're going to expand upon that to make our character move on the horizontal axis as well and make it look to the mouse as it moves. And we're going to take it step by step, okay? That's it for now. If you liked the content, consider liking and subscribing to the channel, and I'll see you in the next one. Bye!